Okay, we've had a request to try to show how to work limits or attempt how to work limit problems when you have radical expressions involved. And in the last video we worked an example, and if you have something where you might have the difference of two radicals, or you're adding two radical expressions together, or you have some number plus or minus a radical expression, many times you can get your problem into a more workable form if you multiply through by the conjugate of the radical expression. So for example, this problem here we have 2 minus the square root of x plus 3 divided by x minus 1. And if we multiply the conjugate of this, first of all, is going to be 2 plus the square root of x plus 3. And if I multiply the numerator by that, then I have to multiply the denominator by that, because this divided by itself is just 1, so I'm just multiplying this by 1, perfectly valid. And this will be equal to, now up here in the numerator, we're going to have 2 times 2 is 4. These square root quantities cancel each other out. That's the purpose of working with a conjugate. And we're going to have minus this times this, so that would just be x plus 3. The square root sign goes away. Now down here in the denominator we have x minus 1 times 2 plus the square root of x plus 3. So we had our original problem was written out like this. Now we do this, and here the radical expression, the radical term, is now down here in the denominator. So we really did ourselves any good. Well, let's see what the numerator gives us first before we make that decision. Here we have 4 minus x plus 3. 4 minus 3 is 1, so we have 1 minus x divided by x minus 1 times 2 plus the square root of x plus 3. And we want to take the limit of this now as x approaches 1. And if we put a 1 here, that's going to be 0 and that's going to be 0, so we're not prepared to take that step yet. But if we multiply this by negative 1, that'll become x minus 1. So let's do that. If I multiply the top by negative 1, I have to multiply the denominator by negative 1. Negative 1 divided by negative 1 is just 1, so I'm multiplying this by 1. That's perfectly legitimate. So up here we're going to have x minus 1. And then down here we're going to have x minus 1 times, multiply through by negative 1, that's going to be negative 2 minus the square root of x plus 3. And we want limits when x approaches 1. So these troublesome terms cancel each other out. So that did make this little manipulation worthwhile, because now we can put in our value for x, and that's going to be equal to 1 over negative 2 minus 1 plus 3 is 4, the square root of 4 is 2. So this would be negative 2 minus 2 is negative 4, so that's minus 1/4. So this here has a limit of negative 1/4. And again, if we hadn't gone through this step here, though, it's very unlikely that we would have been able to solve for that. So that worked out pretty well. Let's try it in this example. It's a little bit convoluted, but it does work if you kind of follow it through. And here we have the square root of n squared plus n minus the square root of n squared plus 10. We want to take a limit as n approaches infinity. So again, let's try multiplying by its conjugate. We're going to have conjugate is this, n squared plus n plus the square root of n squared plus 10. And we'll have to divide by that also. So that I'm multiplying this by 1. This divided by itself is 1. Perfectly legitimate. What do we get out of it? This times this, that's going to be n squared plus n. And these terms drop out. And here we have this times this minus n squared plus 10 in the numerator. Down here, we've got these square root signs. So here we have the difference of two radicals. Now here we have two radicals added together down in the denominator. Has that really gained us anything? Let's have a close look at the numerator before we decide that. Here we have n squared minus n squared. Here we have n minus 10. So up here we have n minus 10. And we want to take the limit as n approaches infinity. Now, what we can look at is what happens then. Remember, when we had problems like this before, we had a term going to infinity, and we had that variable in the numerator and in the denominator, and we tried dividing the whole expression by that variable, whatever the highest power of that variable was. And here we have n, and the highest power is just 1. We have an n squared, but we're taking square roots of that. So what happens then if we divide the numerator by n and we divide the denominator by n? N divided by n is 1, minus 10 divided by n. And down here we have this divided by n, and that is divided by n. And we can take the n inside of the square root sign, where the square root n squared over n plus n over n squared. It should be n squared right here. N squared divided by n squared is 1. So the square root of 1 plus n divided by n squared is 1 over n. And we have plus this term. Take this up in here, it's going to be n squared. N squared divided by n squared is 1 plus we're going to have 10 divided by n squared. Okay, now we want to know, looking at this expression right here, what happens when n goes to infinity. So this is going to be 0. That right there will be 0. That right there will be 0. And this will equal 1 divided by square root of 1 is 1, plus the square root of 1 is 1/2. So this limit right here equals 1/2. There's no way that you could ever look at a problem like this and just somehow determine just by looking at it that this limit must be 1/2. Again, we got it by multiplying q by the conjugate of this expression, top and bottom, of course. And then once we did that, it was just a matter of following through with some algebra, and we do get a valid limit for this expression here. So these are two more examples here that we dug out of how to handle limits when you have these radical expressions involved. And again, many times it's very worthwhile multiplying q by the conjugate, top and bottom here, so we're essentially just multiplying by 1. And once you do that, kind of look at the algebra, look what's in the numerator, see if there's other terms that will cancel, and that many times that can get you to the right answer. Okay, that's it for this video. Hope it was worthwhile. Come back and join us for some more videos, and we'll try and solve some more problems.